Hello, welcome back. Today we're doing notes 6C on the electromagnetic spectrum. Normally I would tell you to do the quick review and then come back, but this time I am going to want you to do the quick review with me. If you are at home, you're going to have a hard time drawing in the lines from home. You could do it on canvas and then Control V to paste in the image and then shrink it to the right size, but that's a lot of work. So if you are at home doing this, please just write down the words, type in the words in the blanks, and then come get a copy of the notes from me when you're back that has the lines drawn on it. So here we go. Since this is a mirror that curves out, this is a convex mirror. It reflects light rays like this. So the light that hits it bounces out and away. And this is curving in. So this is a concave mirror. Yes, it's technically supposed to be like that, but I couldn't get that shape to exist in Word when I made these notes. And it reflects light rays like this, so it bounces in and down. So this is why you can end up with an upside down image when you use a concave mirror or magnifying mirror. So this is curving in, so this is a concave lens, and it refracts light. The light goes through and bends out and away in a, oh, that's terrible, in a concave lens. There we go. And this one is a convex lens. It refracts light rays like this. So the light that goes through bends in and down. And this is why you can get a upside down image with a magnifying glass. Concave mirrors are used for makeup or magnification. Convex mirrors are used for security. Concave lenses are used for nearsighted glasses. And convex lenses are used for far-sighted glasses. All right, pause that if you need to get that typed in, but I'm going to erase and move ahead. What's even more amazing about light being bounced, and what's that word? Right, reflection and bent. What's the word for that one? Good, refraction. Is that there's more to it than just the light we see. We are only able to see a tiny bit of these types of waves that are out there. Electromagnetic energy is the energy of light as well as other forms of radiation. These types of waves can travel through space, so they are transverse and carry electric and magnetic energy. The range of electromagnetic waves is called the electromagnetic spectrum. And again, pause that if you need to get it written down, but I'm going to move ahead. So when you Google electromagnetic spectrum, you're going to see something like this. Or with lots and lots more on it. Like some of these are just full of information. But you can see just from what we've got here that a radio wave is about the length of a football field. From crest to crest is about the length of a full football field. So we're talking about 100 yards or 100 meters. So about 100 yards. 100 meters is 30 inches longer than 100 yards. And then microwaves are actually radio waves. So they are the radio waves that have the shortest wavelengths. And there, all of a sudden, we've got a wavelength that from crest to crest is the size of a bee. So we've gone from football field from crest to crest to bee from crest to crest, just in radio waves. So you can imagine how complicated this whole thing can get. So as you can see in the chart above, the part of the electromagnetic spectrum that we can see, called visible light, is just a small portion of the entire spectrum. I want you to look at the image for a moment and write down an observation. So I have given you that radio waves are the length of a football field. I want you to look at these other things and look at these other things that you could compare and say that a something is about the length of a something, and write that on the sentence, on the blank here. So I said radio waves are about the length of a football field. I want you to come up with your own. And you're going to work on that. You're going to pause and work on that, but I'm going to move on. So we're going to use this chart to pay attention to wavelength. So what is the wavelength? How do we measure wavelength in a transverse wave? From crest to crest or trough to trough. So what was that for a radio wave? So looking back at the, I'm going to scroll up and the words are still going to be there, but that's okay. So radio wave is 10 to the second meters. So 10 to the second meters. So 100 meters. So about the length of a football field. So what's the wavelength of X-rays? Can you look up and see? Right, 10 to the negative 10th meters. About the length of an atom. Wow, that is tiny. So using this chart, what do we notice about frequency? When we have long wavelengths, when it's a long way from crest to crest, we don't have much frequency. We don't have many waves. But when we have short wavelengths from crest to crest, we get a lot of waves. So longer wavelength equals lower frequency. Shorter wavelength equals higher frequency. So the relationship is inverse. As wavelength goes up, frequency goes down. As wavelength goes down, frequency goes up. So when we have a long wavelength, we have a low frequency. When we have a short wavelength, we have a high frequency. Again, pause if you need to, but I'm going to erase and move ahead. These two are just some examples of the types of images that you might find if you Google search electromagnetic spectrum. I really like both of these because they are so full of information. This one even tells you the frequency of the waves and the amount of energy of the wave, as well as sources of that type of radiation. And then on this one, it tells us what kinds penetrate Earth's atmosphere and the temperature of those things. So like you can find out all kinds of different information about the EM spectrum, just depending on which chart you looked at. So now let's talk about, excuse me, the different types of electromagnetic energy. So radio waves. Radio waves are the EM waves with the longest wavelengths and the lowest frequencies. Like all EM waves, they can travel through space. So the sun actually produces the whole electromagnetic spectrum. They are broadcast and received through antenna. Different radio stations broadcast at different frequencies. So when you change the radio station to another station from like 1021 to 1027 to 1037 to whatever you're listening to, you're actually changing the wavelength of the frequency that your antenna is receiving at. So each of those wavelengths, each of those radio stations broadcast at whatever frequency they're supposed to broadcast at. That's where that 1021.1 and all that stuff comes from. That's their exact frequency that they're broadcasting at. What's really cool is that radio waves with the shortest wavelengths and the highest frequencies, but they're still radio waves, those are microwaves. And microwaves are used for cell phones and to cook your food. All right, again, if you need to pause to get that, please do, but I'm going to erase it and move on. Infrared waves have shorter wavelengths and higher frequencies than radio waves. Infra is a Latin prefix, which you should know already, meaning, below. So infrared means below red, and that makes sense because the next type of wave in the EM spectrum is red visible light. You can also often feel the energy of infrared rays as heat Oh, you feel the energy of. Oh, I guess the wave shortest. Sorry. You can feel the shortest. There it is. Infrared rays as heat. So these are often called heat rays. So this is when someone uses an infrared camera, like it's pitch black dark, but you use this infrared camera and you can see the body heat that's being given off by living things. That's infrared. It's just taking advantage of the fact that we can see the heat coming off of things. If you have the right kind of equipment. We can't see it, but we can use something that can. The EM waves that we can see are called visible light. The longest wavelengths of visible light are red. As the wavelengths decrease and frequencies increase, that whole up and down thing again, the other colors of light become visible. The shortest wavelengths of visible light are violet. So can you name the colors of visible light in order of wavelength from longest to shortest? You think you can't, but you can. If red has the longest and violet has the shortest, right, Roy G. Biv, exactly. Red, orange, yellow, green, blue, indigo, and violet. And I'm not going to write all of that out because you know how to spell your colors, or you can Google it if you can't. All right, again, I'm going to clear it. Pause it if you need to. EM waves that have wavelengths just shorter than violet visible light are called ultraviolet or UV rays. Ultra is the Latin prefix for, you should know this one too, good, beyond. So ultraviolet means beyond violet. Again, this makes a lot of sense because the last type of wave in the EM spectrum was visible violet light. So the next thing above it or beyond it is UV. UV rays are what damage your skin when you're out in the sun for too long. So on a normal sunny day, the visible light and the infrared drive you inside before the UV has a chance to do a lot of damage. But on those days when it's cloudy and the infrared and the visible are blocked by the clouds, but the UV is not, those are the days you get a wicked sunburn because you don't feel it. You don't feel the heat and you don't feel the light. You don't see the light. And so it makes it so that you end up with a really bad sunburn. All right, again, pause that if you need to. I'm going to move on. X-rays are EM waves with very short wavelengths with frequencies just a little higher than UV rays. Because of their high frequency, X-rays carry more energy than UV rays and can penetrate most matter. Dense matter, such as bone or lead, absorbs X-rays and does not allow them to pass through. Too much exposure to X-rays can cause cancer. So often when you have an X-ray, a lead apron is used to cover your body. So if you've ever gotten an X-ray and they put that big blanket, especially a dental X-ray, and they put that blanket over your body, or you get an X-ray of your arm and they put a blanket over the rest of your body, that's because those X-rays are going to penetrate your whole body unless you've got something protecting it. So you get that blanket of lead, which protects your body from the X-rays. And then your bone absorbs those X-rays, and that's why your bones glow on the film. So that's the fact that your bones absorb the X-rays is why it works. And then we've got gamma. Then we've got gamma rays. Gamma rays have the shortest wavelengths and the highest frequencies of all the EM spectrum. Because of the great amount of energy they carry, they are the most penetrating of all the EM waves. So this is the type of stuff that causes damage in whenever you're talking about being worried about nuclear radiation. It's gamma radiation that you're worried about. So some radioactive substances and nuclear reactions produce gamma rays, which can cause serious illness. Fortunately, Earth's atmosphere blocks gamma rays from space. So, thank goodness our atmosphere protects us. Remember how I said the sun produces all of it. So it's a good thing that we have an atmosphere that protects us from it, or otherwise we would be in big trouble. All right, that is it for Note 6C. Make sure you get those written down before this coming Thursday because that's going to be the day of the quiz. I hope you have a lovely day and make good decisions. Bye.